Good morning, guys. Anjani Kumar here, dealing instrumentation subject for a final year electrical students. In the last sessions, we have successfully completed our concepts of LVDT and strain gauge. Alright, so in detail, we discussed about these two concepts, right? So these two concepts are very, very important for your board exams, right? Definitely, you won't expect a paper without these questions. Alright, so I'm suggesting you people definitely you should follow my videos and try to see at least once these concepts, right? It will be very helpful for you. Okay, so now we are going to discuss some other transducers, right? So these are two important transducers in our syllabus. We have another 4 transducers in our syllabus, right? So we just want to discuss about all these 4 transducers in detail, right? In this, the first we are going to discuss is thermocouple, right? Second one is thermistor, right? So after that we discussed about piezoelectric transducer, right? So after that we'll discuss about photodiode, right? So after that small concept of synchros, right? So these are the remaining concepts in our unit, right? If we completed these 4 or 5 things successfully, definitely we will end this entire unit, right? So remaining concept that what are the different transducers that we are going to discuss is first is a thermocouple. After that we'll discuss about thermistor. These are very, very simple concepts, right? Right, if you follow my videos, definitely you will understand. You will grab the total information regarding these 4 concepts, right? Piezoelectric transducer and photodiode and synchros. Alright. Today in this session, we are going to discuss about the concept of thermocouple. Right? Shall we start? Right. So now we are going to start the concept of thermocouple. Right. So thermocouple is nothing but a temperature transducer. Alright. So thermocouple is nothing but a temperature transducer. Right. So what is a thermocouple? So in this we are going to, so what are the things that we are going to discuss means, the first is a construction or else a working principle, whatever it may be. Construction, working principle, and metals, what we are using to form these thermocouples and all these things. After that we'll discuss about some advantages and disadvantages. Alright, so these are the concepts that we are going to discuss under thermocouple. Alright, okay. So what is a thermocouple? Thermocouple is nothing but temperature transducer. Right, so whatever the temperature which is converted to electrical energy, you know the principle of a transducer. Transducer is a device which converts non-electrical quantity into electrical quantity. So the name itself indicates thermocouple means temperature transducer. You will say the definition. So it will convert a temperature in terms of voltage. So that is nothing but a temperature transducer. We know that the thermocouple is an active transducer. Right. So thermocouple is nothing but is an active transducer. You know about active transducer. So what is meant by active transducer? So what is active transducer? This type of transducer doesn't require external electrical supply, doesn't require an auxiliary supply for its operation. So that's why till now we discussed about a passive transducer. So LVDT, right? Strain gauge, resistive transducer, inductive transducer, capacitive transducer. These are a passive transducer. Now we are going to discuss today active transducer. So one of the best active transducer is a thermocouple. I hope it's clear. So it's nothing but a temperature detector, temperature transducer. It's nothing but an active transducer, right? And after that, it can be used to measure the change in temperature in terms of voltages, right? So how you can measure the change in temperature? Change in temperature. So we can find the change in temperature in a room or in a metals, right? Change in temperature in terms of EMF generated. In terms of EMF generated in a metals, right? So if you want to find the temperature in a metal, how much temperature generated in a metal, so with the help of in terms of voltages, so it's like a temperature transducer. I hope it's clear, right? So now we'll see what is a working principle. After that we'll see the construction itself, right? So how it can measure the temperature in terms of voltages, right? So in a metals, right? So working principle. Right. So thermocouple. So thermocouple, the name itself indicates couple. Right? Right? So when two dissimilar metals, so which are joined together, it forms two junctions. Right? Two dissimilar metals. See, this is one type of a metal. Right? This is another type of a metal. Another type of a metal. So this is called a metal 1. This is metal 2. Right? Two dissimilar metals joined together, it forms two junctions. So we can call it as a junction 1 and junction 2. Right? So one junction we can call it as a cold junction. Right? Cold junction. Right? Another junction we can call it as a hot junction. Right? See, when two dissimilar metal, if you want to operate the thermocouple, we require at least two metals, right? Minimum two metals. If the two metals are joined together, it forms a two junction, right? So one junction we can call it as a cold junction, another junction we can call it as a hot junction. So cold junction is a reference temperature, right? It's nothing but reference, so it's nothing but 0 degrees centigrade, right? So in a hot junction, so whatever the temperature, if you want to apply across the hot junction, right? See, when two dissimilar metals, which are, I just want to explain the working principle only. So after that, in the construction itself, you will know, right? When two dissimilar metals, which are joined together, it forms a two junction. So one junction we can call it as a cold junction, another junction we can call it as a hot junction. So cold junction we can call it as a reference junction. So I think that it was a 0 degree centigrade junction, right? So whatever the temperature, if you want to find, that can be applied across the hot junction, right? The change in the temperature, there will be a change in difference in a temperature, no? It will generate the EMF, right? So that EMF we can calculate it, we can be calibrated scale. right? One moving coil instrument is there that will reads how much change in temperature, that much voltage is going to be generated. See, so that is a working principle. The change in temperature, it will generate the voltage, EMF generated, right? Change in temperature, it will use the EMF, and that EMF we can detect it from the meter, calibrated meter itself. That means whatever the change in temperature, which is converted to voltage. Hope it's clear, right? I'll explain here. Changes in temperature differences will produces the EMFs, right? Will produces the EMF, right? Each and every junction, it will produces the EMF, right? So whatever the EMF that is developed by the change in temperature, it will be calibrated, it will be find out from the moving coil meter or a voltmeter or whatever it may be. So that EMF, so we can find with voltmeter or moving coil meter, right? So this is the working principle. I hope it's clear. Nothing is there. When two dissimilar metals which are joined together, it will forms a two junction. One junction we can call it as a cold junction, which is a reference junction. Another junction we can call it as a hot junction. Alright, so whatever the temperature, if you want to find that much temperature, that can be applied across the hot junction, right? The change in temperature difference will produce the EMF. So that EMF we can calibrate it with the help of instrument like voltmeter or a moving coil meter. So that my temperature, which is converted to voltage itself. See, now you will find the question how the temperature difference will generate the voltage. That's your concept. That's your question, right? You will have a question, sir. You are saying that the temperature difference will produce the EMF. How it will be, right? So with this can explain with the help of three effects. Right? Temperature difference produces EMF by three effects. Alright, so what are that effects? The first one we can call it as a Seebeck effect. Alright, and the second one is Peltier effect. And the third one is a Thomson effect. Right? These effects are physical sciences. Alright? So what I am saying means, whenever the temperature changes, there will be an EMF generated. So how you are telling that whenever the temperature changes, EMF generated? So that can be explained with the help of three effects. The first one is a Seebeck effect, and the second one is a Peltier effect, and third one is a Thomson effect. The first I'll discuss about Seebeck effect. Alright. So what the Seebeck scientist says that when two metals are joined together, when two dissimilar metals which are joined together, right? So when two dissimilar metals join together, it forms two junctions, right? And EMF generated at each junction. Right? So when two dissimilar metals which are joined together, it forms a two junction, each and junction J1 and J2. So there will be an EMF generated at each junction. That the Seebeck effect says. Right? So junction J1 you will get the EMF E1, junction J2 you will get the EMF E2. Right? Right, how much amount of EMF generated depends on what type of metals that you are choosing, right? Depends on metals you are choosing. Great. So what is the Seebeck effect? Means when two dissimilar metals which are joined together, it forms a two junction, right? So there will be electromotive force, there will be a voltage generated at each junction. That's the simple thing that what he said. Alright. So the amount of EMF depends on the metals that you are joining. Right? How the EMF generated, he won't said that how the EMF generated. Right? That can be explained with the help of Peltier effect. So it's a Peltier, not Peltier. Next effect is a Peltier effect. Right? So when Peltier effect states that when two dissimilar metal join together, it forms a two junction. Right? So there will be an EMF generated. Due to the change in temperature. At each junction. Alright? So what he is saying means, Peltier said that when two dissimilar metals which are joined together, definitely it will form a two junction. Alright? So what Seebeck effect said that definitely at the junction the EMF will be generated. But what the Peltier says that, so there will be a EMF generated. So how that EMF generated means due to the change in temperature, the EMF will be generated in the circuit. Hope it's clear. How the EMF generated means due to the change in temperature, the EMF is generated. So this effect only we are using our thermocouple principle. Right? So another effect is called Thomson effect. Alright. So what the Thomson effect says that when two dissimilar metals are joined together, it forms two junctions. Right? So due to the temperature changes, EMF will be generated. So you will find the EMF throughout the length of the metal. You will find the EMF. So that's the Thomson effect. Right? Forms a two junction. So EMF generated due to change in temperature, and that EMF will flow. So you can find at any point in the metal, flow and find at any point in the metal. So suppose if these two are the metals, so which are joined together, this is J2 and this is J1. So junction J1 and J2. Right? So definitely what's the Seebeck effect says that at J1, J2 you will find the EMF E1, E2. That's it. And what's the Peltier effect said that how the EMF generated by changing the temperature J2 minus J1, right? Temperature changes. By changing the temperature, the EMF is generated. So what the Thomson effect says that whatever the EMF generated, that will flow along the length of the line. Right? At any point, you will find your voltages. Correct? So at any point, you will find the voltage. Right? So you will find the difference in the voltage or whatever it may be, voltage, EMF, you can find at any point in the metal. So those are the three effects. I hope it's clear. How the thermocouple working is, thermocouple works to find the temperature difference in a metal. So how the temperature difference you can find the change in temperature with respect to the voltage, right? So that's why we can call it as a temperature transducer. Right? So what is the working principle? When two dissimilar metals which are joined together, it forms a two junction. Right? One junction we can call it as a cold junction, another junction we can call it as a hot junction. So cold junction we can call it as a reference junction, hot junction we can call it as a whatever the unknown temperature that you are going to apply, that can be applied across the hot junction. According to this Seebeck effect, Peltier effect, or Thomson effect, so there will be a change in temperature from the junction J1 and J2. There will be an EMF generated. So that EMF that we can find with the help of a moving coil meter or voltmeter itself. Alright, so whenever the change in temperature, which is directly proportional to the voltage that you are getting. So that is the working principle. So what is the effect? Seebeck effect, Peltier effect, and Thomson effect says that Seebeck effect means when two dissimilar metals which are joined together, it forms a two junction, right? So there will be a EMF generated across the two junction. That's Seebeck effect said that, right? Next, what's the Peltier said that? So definitely there will be an EMF generated. How that EMF generated? So that EMF generated on the basis of change in temperature between the two junction. That is a Peltier effect. And what's the Thomson effect says that? So definitely when two dissimilar metals which are joined together, it forms a two junctions. Definitely the EMF is generated between the change in temperature, right? So that EMF that can be flowed throughout the entire length of the line. So whatever the part, so wherever the metals length, you can find your EMF, right? So along the length of the line, the EMF will be produced. So that those are the three effects. Now we'll see the construction of a thermocouple. I hope it's clear. Alright. So thermocouple, which is used to measure the change in temperature in terms of voltage. That's why we can call it as a temperature transducer. Alright. See. So how the construction means? So this is a metal 1, this is a metal 2, this is junction J1 and this is junction J2. it is indicating meter, right? See, so junction J1 we can call it as a cold, so J1 is hot junction, so it is at 0 degrees centigrade, so we can call it as a reference. I hope it's clear. So when two dissimilar metals which are joined together, it forms a two junction. So one junction we can call it as a cold junction, another junction we can call it as a hot junction. Alright? So whatever the unknown temperature that you are going to apply it across the hot junction, due to the change in temperature, there will be a deflection in the meter. It will shows the voltage. So that is a working principle. Now we'll see basically how it will work. Right? So basically how it will work. Right? So whenever the change in temperature, so that means E1 and E2. Right? Whenever the change in temperature, see, so when you apply a junction G1, we can call it as a cold junction, hot junction is there. Alright? So at the time of starting, the both junctions are equal potential. That means equal temperature. So whatever the voltage E1 and E2 equal to 0, E1 equal to E2, that means change in voltage equal to 0. There is no deflection. Hope it's clear. So this is 0 degree centigrade. So whatever the temperature that you applied here, so that definitely there will be a change in temperature. So when there is a change in temperature means, so there will be a current will flow. Alright. So due to that current, the meter will start deflecting. Alright. So the deflection of a meter, it will be a moving coil meter or a voltmeter. So how much deflection, that is that much voltage. How that voltage came? By applying a change in temperature. So this is actually the working principle. Alright. So when change in temperature is created, there will be a current flow through the metal. So with that current, the meter deflection will be there. So due to the deflection, you can find out how much voltage, how much current is going to be generated. So how much current is generated, it depends on the metal that you are using. Alright, we'll see what type of metals that we are using in these thermocouples and all these things. I hope it's clear. Construction and working principle. Now what is a mathematical relationship between the temperature and the EMF? Right, we'll see. Right. So whatever the EMF generated, that is equal to A into delta theta plus B into delta theta whole square. Right. So E we can call it as a EMF generated. Right. So delta theta is nothing but change in temperature. Right. A, B are constants. Right. So this is a mathematical relationship between EMF generated and the change in temperature. Right. So now we are going to eliminate the quadratic term here. So that how we are just eliminating to make that scale is a linear, right? So now if you eliminate this thing, so what we can get it as E is equal to A into delta theta. So why we are eliminating means, so why you are eliminating means in order to get the linear scale, right? If it is a non-linear, it will be very difficult to find out the voltage. Right. So for this we need to eliminate the B value. So if you want to eliminate the B value, it should be very less. So if you want to eliminate this, choose that type of metals. Right. Metals that you are choosing. So whatever the metals that you are going to choose, that is very less value of B. So with that you have to eliminate this factor. Alright, so then you'll get the equation as E is equal to A into delta theta. Alright, and now we'll see. E is equal to A into delta theta. So remaining term is we are eliminating because the B value is very small. That means what that type of a metals that you are choosing. Alright. Then you will get the relationship. So del theta is equal to E by A. So whatever the change in temperature is directly proportional to whatever the EMF generated. That means whatever the input increases, the output also increases linearly. So it will be more useful for us in order to get the linear scale. Hope it's clear. So this is the mathematical representation of a relationship between the EMF and the change in temperature. Hope it's clear. Alright. Now we'll see, I'll explain with the help of two different metals. So what are the metals? With that I'll explain. I'll go for iron and constantan, how the thermistor, how the thermocouple will see. So with it, it's clear, we don't have any external supply in order to operate these thermocouple. Do you have any external supply for this operation? No, you didn't see that external supply, just heating your element, that's it. So whatever the temperature if you want to find, that can be applied across the hot junction. Alright. Now we'll see how it will be. Right? So how the real life, how you are constructing a thermocouple in your useful life, it's like this. This is called iron and constantan materials. So we can call it iron leads, iron metal leads, constantan metal leads, right? Temperature adjustment device. Right, so this is a copper leads. So this one copper leads, and this is a meter. So these are the two junctions, J1 and J2. Hope it's clear. Alright. So this is your useful life example, like useful. Now you are using these type of thermocouples with made up of iron and constantan. Right, when two dissimilar metals which are joined together, it forms a junction, so there will be a change in temperature. So whatever that temperature, if you want to find out the unknown temperature, that can be applied, so there will be a change in temperature. So this is called a temperature adjustment. If it's more, definitely your iron and constants will get damaged, right? Alright, so with this we have a device called temperature adjustment device. With that change in temperature will produce the EMF. That EMF we can be measured across the meter. So moving coil meter, voltmeter, whatever it may be. So this is the basic construction of a thermocouple. Now what are the metals that we are using in your thermocouple? We'll have a different metals. We'll see here. Right. The first one is iron and constantan, right? And second one is copper, constantan, right? Chromal, constantan, right? Chromal, alumel, right? Rhodium and alumel. So these are the combination of metals that we are using. So why these type of combinations you are using means in order to make your scale is a linear scale, right? So whatever the value of B should be very less. So what are the metals means? Iron and constantan, chromal and constantan, copper and constant, and basically we go for iron and constant, and material only we can use in a thermocouple itself, right? Chromal constanter, chromal alumel, and rhodium and alumel. So these are the combination of metals that we are using in this type of thermocouples. Hope it's clear, right? So this is about thermocouple. So what we discussed till now means thermocouple means a temperature transducer. It will measure the change in temperature in terms of voltages, right? How it can, so it's like an active transducer. It doesn't require any external supply. So when two dissimilar metals which are joined together, it forms a two junction. One junction we can call it as a cold junction or a reference junction. Another junction we can call it as a hot junction. So whatever the unknown temperature that you are going to apply across the hot junction. So definitely according to the Seebeck, Peltier and Thomson effect, so there is a change in temperature will produces the EMF. So whatever the EMF that we can calibrated in terms of moving coil meter inserted on the metals, alright. So whatever the voltage that you are getting, which is directly proportional to the EMF, whatever the change in temperature. So we'll see the mathematical equation and also we'll see the construction, right, and all these things. So this is about what are the metals also we discussed, right. So what are the advantages and disadvantages of a thermocouple? Now we'll see the advantages and disadvantages. Alright. So it is used to measure the temperature very high range temperature at around 2600 degrees centigrade. So up to 2600 degree centigrade also we can measure this type of thermocouple. We can measure the temperature with the help of these type of thermocouples, right? And after that, second one is, so whatever unknown temperature that you are getting, that means whatever unknown temperature you are getting with say less time lag, right? So you are getting a response which is less time. So that means here one more advantage is, so whatever the heating, that means junction, which is one part, that means which is not nearer to the whatever the voltmeter, and so junction is somewhere and the measurand is somewhere. I hope it's clear. So junction is different, like so that means we are providing separated distance between the junction and the meter that you are calculating, right? Whatever the junction which is far away from the meter that you are having. So that is one more advantages and disadvantages also, alright. So these are the advantages of a thermocouple. So temperature should be very high, less time lag, 2000 up to 2600 degrees centigrade also we can get with the help of thermocouples. And whatever the less time we are getting a response, and here a junction point which is very far away from the meter. So that means there will be some heat distribution, will get some less value of heat distribution between the meter and the junction points, right? Those are the advantages and disadvantages. The first one is it is less accurate, right? And second one, you require definitely a proper shielding. So you require a proper shielding for a long life of instrument, right? For a long life we require a proper shielding because the temperature should be very high, then the metal will get damaged, right? So after that, so the junction and the meters are different places, so definitely it will lead an error, right? So the junction and a detector. or at different places, it will leads an error, right? So these are the disadvantages. It will give a less accurate, and we require a proper shielding, right, for a long life of this thermocouple instruments. And after that it will reach an error value because your junction and the detector will place in a different places, so it will lead some error while reading the output, right? So this is the whole concept of thermocouple. I think I explained in detail about all the thermocouple, how it's working, how the construction will be, and mathematical analysis, right? And different metals, what we are using a thermocouple, and all these things. Thank you for now. In the next class, we discussed about the next transducer called a thermistor. Alright, I hope it's clear. Thank you for now.